Okay, I decided to record myself going over these answers for this take-home quiz. So make sure you understand everything on this. So the whole idea, if you're given a quadratic in vertex form, there's no work. We can look at the rule and we can instantly state the vertex. So all I'm concerned about is x plus 3. I know that's to the left. Therefore, I know my x value has to be negative 3. So when we plot this, when we graph this, we're going to have negative 3 as the x value, and it's down 9. So the y value of your vertex is negative 9. That's the first point I can plot. I can do that before we pick up a calculator. We're going to be right here at negative 3, negative 9. Okay. And I also know since there's no negative in front, it's going to be a stretch. So the U is going to be a little bit skinnier. It's a vertical stretch, but it's a positive number, which will make the vertex a minimum. And I know my minimum Y value is going to be a negative 9. Okay. So I'm going to type this into my calculator just so I can gather some more points. So go to the Y equals screen, 2 parentheses X plus 3, close the parentheses, square it, and then minus 9. And we know it's going to be down here is our vertex. So knowing where the vertex is, that's where I want to position my table. So let me have my table start at negative 3. And I'm going to position it so I can see 2 points above the vertex and 2 points below. And we're going to see everything's going to be symmetrical. So I'm going to plot the point negative 5, negative 1. So there's a nice dot on my graph. I'll do negative 4 down 7. 1, 2, 3, 4, 5, 6, 7. And then we're going to see the idea of symmetry. So I know negative 2 is down negative 7. And I know negative 1, negative 1. Okay. 5 dots is all I ask. You can do more if you want, if you can fit more, but this gives us a nice looking parabola. Okay. So then to answer the rest of these questions, the axis of symmetry, do not get wrong. If you have the correct x value of your vertex, you simply say x equals the x value of your vertex. Domain is going to be all reals. I can have x be any number I want. My outcomes, I can see from my table, all my outcomes are going to be above negative 9. Okay, it can equal negative 9, but all the other outcomes I can see from my graph, it is all going up. So the easiest way to say that is y values are greater or equal to negative 9. Okay, since we have a minimum, you look at this graph left to right, we are descending on the left. We're going downhill on the left. So let's scroll down so you can see it. On the left, we go downhill. When we hit the vertex, we're going to go increase to the right of the vertex. Okay? Should be very easy to understand when a quadratic is in vertex form. Okay? Now, standard form, a little bit more difficult to be able to know where the vertex is. Okay? So before I even type this into my calculator, I am going to do this. I'm going to calculate what the opposite of b over 2a is. So I'm going to do that on my blank screen. So let me clear that. And if you hit alpha y equals option 1, we have this. This way, we're not going to mess up this calculation. So I take the opposite of b. Well, a is negative 1/2. B is a negative 4. So in my calculator, I'm going to type in a positive 4. So it's the opposite of negative 4 is a 4. Go down to the bottom to my denominator, and I'm going to take 2 times negative 1/2, which I can just put in as a 0.5. Okay, negative 0.5 is the same as negative 1/2. I hit enter, and I'm going to know for this problem that my line of symmetry is going to be negative 4. Okay, so I can put in the x value is going to be negative 4. I don't know the y value yet, and I do know the axis of symmetry. So when I type this in at the y equals screen, I should just confirm that. Okay, we should be able to see that. So negative 0.5 x squared, and then minus 4x, and then plus 1. Okay, we can hit graph just to see. I feel good about my line of symmetry. It looks like it would be cut in half at -4. I'm going to go to my table, and I'm going to position my table so I can see when x is -4, we're up at 9. Okay, and that point's going to be a maximum. Okay, so I'm going to plot 1, 2, 3, 4 up, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is the highest point. So then I just want to use my table, and we'll plot, I'll go -8 up 1, and I'll do -6 up 7. 1, 2, 3, 4, 5, 6, 7. And we're going to see the idea of symmetry. So when we do symmetry, I'm going to have -2 up 7. And then if I go to 0, we have an outcome of 1. Okay. So again, it's okay to plot decimals, but I like plotting nice integer values. So there's my u. It's upside down, which makes my vertex a max. We already have the line of symmetry. We already know that the domain for every quadratic is going to be all reals. But now my range, since my largest y value is 9, that means all my other y values are going to be below 9. So 9 is the peak. Everything else is going to be less than or equal to 9. So now here it's going uphill on the left. So it's increasing on the left, decreasing on the right. Okay, and the reason is we have a max. Okay, so hopefully that makes sense for that first page. The second page, I'm having you translate a quadratic just x squared. So it says, write a function who's translated 7 units to the left. So as soon as you know, so it's g of x, you have a horizontal movement, you need to go and have parentheses. And with the x, we have to then add or subtract. So in this case, since I'm going to the left, I am going to add a 7. Okay, now make sure the square is on the outside. Okay, and then we have plus 11. If you want to double check that, it should be real easy to type this into my calculator and just confirm that we move to the left. Oh, I have to change my window. So we're up here. So let me go to Windows and let's change the Y to say a 20. Okay, now I can see we move 1, 2, 3, 4, 5, 6, 7 to the left and up 11. Okay, so my rule is reflected in the graph. Okay, so then the next thing we're supposed to do, go back to the parent function, and we are going to do a vertical stretch with a factor of 3. That's super easy. You just put a 3 in front of the x squared, and then I'm going to have you reflect it. So you just make the 3 a negative. Okay, that's all we're doing. Okay. This next part, I just want you to be able to compare these graphs. You could type all of them into your calculator, but I know the widest graph is going to be the one that has a value in front that's closest to 0. It's a fraction between 0 and 1 is a shrink, which makes the graph wider. It looks like f of x is going to be the widest graph because of that 0.5 in front. Okay, which is the narrowest? That's the one with the biggest number in front. Again, disregard the negative. You have a 2 here. That's a stretch, but 3 is even more of a stretch. So that's going to be g of x. Okay. And finally, they ask, which parallels have the same axis of symmetry? This is the only one that's shifted. Both of these have a line of symmetry of 0. Okay, this is just down 2. This is up 1. So f of x and h of x. Okay, and you could confirm that on a calculator. You wanted to make sure I can go to my y equals screen and I can type in 0.5x squared minus 2, and I can type in negative 2x squared plus 1. We're going to see that we have the same line of symmetry. Okay, right there, cuts the x equals 0, cuts both u's in half. Okay, they share the same axis of symmetry. Okay, here we have a problem in standard form, so we want to be able to find the vertex. So the first thing I'm going to do is the opposite of b over 2a. I'm going to calculate this. Okay, so I'm just going to ask the calculator alpha y equals, option 1, I'm going to put a negative 128 up top and 2 times negative 16 on the bottom. It tells me 4. Okay, that can save some time by knowing that ahead of time. Before I go to the y equals screen, I at least know where my x value of my vertex is going to appear. So I'm going to type in negative 16x squared and then plus 128x. I'm not going to look at the graph. The graph, we would have to change the window settings to be able to see it, but it should make sense. And I'm going to show you here. We're going to see that it peaks. The highest point occurs when x is 4. It reaches a height of 256. Then it comes back down. You can see the idea of symmetry. So our vertex is 4 comma, and it was 256. Okay, now I want you to be able to understand, read the problem carefully and know what x represents and what the y represents. So really your input is seconds. So this really means 4 seconds. So after, or I should say at 4 seconds, the water, okay, reaches its highest point of 256, and it's in feet. Okay, that's what you need to be able to understand. So it's a flare. You start counting. You can see after 1 second, it's already at 112. After 2 seconds, it's 192 feet. 3 seconds, 240. 4 seconds, it reaches its highest point. Then it starts coming back down. Okay, so then we're asked to compare. Okay, a second flare. So they don't give us the rule, but they at least tell us 5 seconds it takes to reach its highest point. So which flare travels higher? Obviously the first flare. We can see 256 is greater. So 256 is greater than 196. It's the first flare. Which remains in the air longer? Well, this will be in the air for 8 seconds. You can see it's going to come back and hit the ground after 8 seconds. Well, this would be 10 seconds. So 8 versus 10 seconds, it's the second flare. Okay, so just make sure you have that on your paper. And finally, we have a bonus, which really isn't a bonus. Again, this is only going to be worth 20 points, but I want to make sure you at least have this. Okay, so this is a system. I want you to be able to understand how to set up this system. I'm going to use just X, Y, and Z. Okay, X is going to be my roses, Y is carnations, and Z is going to be my tulips. Okay, so we can buy 3 roses, 2 carnations, and 1 tulip for $20. The second condition, we could buy 6 roses, 2 carnations, and 6 tulips for $50. And then finally, 1 rose, 12 carnations, and 1 tulip for $20. Okay, there's my system. Now, technically, it doesn't matter which letter you choose to get to be opposites. It's easy no matter which ones, but I'm going to get my z's to cancel out. So I'm going to start by multiplying this top by -6. Okay, once I'll have a new equation with just x and y. Then I'm going to take the top and the bottom, and I'm going to multiply one of them by -1. So let me show the work for multiplying everything up top by -6. I'll get -18x minus 12y minus 6z equals -120. The middle equation, I'm just going to keep as is. Do not change anything. And then I'm going to add. Okay. When I add, I'm going to have -12x. I'm going to have -10y. The z's are going, and that's going to be -70. Okay. So I have one new equation where I have x and y. I need another equation, and we didn't use this bottom equation. So what we're going to do then is I'll multiply the top by -1 and add it to the bottom equation. So I'm just going to change everything in my top equation to its opposites. And I'm going to keep the bottom equation as is. So when I add, I get -2x. This is going to be a plus 10y. The z's are going, and I have equals 0. Okay, that's not a special case. I just circle that. And now I can put these two equations. This is an Algebra 1 question. This rule and this rule go on top of each other, and you're going to see that I don't even have to work to get opposites. The y's are going to cancel out right away. So I'm going to have -14x. The y's disappear, equals -70. I take -70 divided by -14. And just like that, we know roses cost $5. Okay. We still need to find y and z, but it should be pretty easy. I can take this x value, plug it in for x. And when I solve, this is a -10 plus 10y equals 0. I add the 10, I divide, and we're going to see just like that, it's $1 for a carnation. Okay. Then I'm going to go back to one of my original, and I have to find z. So we'll just use this bottom. We'll use this bottom equation. I know x is a 5. I'm just going to write it over here. Plus 12 times 1, because a carnation is $1, plus z equals a total of 20. Well, this is 5 plus 12, which is 17. I subtract 17, and now I know my tulips cost $3. So roses, let's write it up here. Roses, $5. Carnations were just $1. And tulips, we now know $3. Okay, that's it. That took 19 minutes to go over all the answers on that take home. So I'm hoping you understand it. Hopefully, when we take a test on this, we will understand every concept, understand vertex form, understand standard form. We will also learn intercept form, but that'll be down the line. So please make sure you have all these correct answers. Thanks for watching. Take care.